Welcome to UGC's E-Pathshala lecture series on computer science. The subject is graphics and visualization, and in today's module we are going to look at task and interaction. The learning objectives for this modules are: this module will introduce the need for task and interaction and visualization, and we can also learn what are the various user tasks that can be carried over the visual that is presented to the end user. We will also learn about the basic interaction techniques that can happen on the visual that is being displayed to the end user, and we will also come to know about various examples of various interactions that can take place over the visuals. The task is a structured set of related activities that are undertaken in a sequence. So as shown in this figure, there are three different entities: the data, the users and the tasks. Data is a set of data that is related to some kind of patient data or treatment plans. The data can be quantitative or abstract kind of data. The data can be of any dimension, say from one dimension to n dimension, or it can be any kind of multivariate kind of data. And we are supposed to handle events and states that are related to data, and the time arrangement can be linear, and instance can also be used as time primitives over the data. The users can be some kind of users who are going to work with the data that is available. So the users can be some kind of medical experts and physicians who are using the data for their own purposes. The tasks that can take place over the data are exploring the effects of clinical actions on a patient's conditions, can be an example of a task that can happen on the data. So using this task, it is possible for the users to perform various activities on the data that is available, and the users can come up with certain conclusion by performing various tasks on the data that is available. If we look at the various task categories, there are various task categories associated with the data. In fact, it can be classified as the interaction primitives. The tasks can be some kind of conversations. The task can be some kind of rhythms and trends that occur in the data. It can be some kind of descriptive statistics that occur on the data, or it can be some kind of community and social network. So let us look at each and every task category in detail. The first one is the interaction primitive. Interaction primitive is one in which the user is supposed to interact with the data as such. So it is possible, this is an example of an interaction primitive where the user is sitting inside the car and he says that I am amazed how the thickness of the wet tarmac on the road really comes through in the video snapshot. He is looking at the video and he says something in response to it. That is an example of interaction primitive. The next kind of task that can happen over the data is conversation. So in the conversation, there are various kind of conversation that can take place. So here this is an example which shows the kind of conversation that can take place. So they say that the soccer practice is on Monday. They also say that there are was so clear. Photos were taken on a picnic day. So these are some kind of conversations that can happen over the photos or over the data that are being captured. The next set of tasks that can happen over the data set is the rhythms and trends. So if you look at the rhythm and trend, this is a timeline that has been taken right from 8 a.m. to 4 p.m. And we can say, if we look at the data set, we can say around 10 a.m. there is a break in between 10 a.m. to 12 p.m. and there is a lunch time between 12 p.m. to 2 p.m. So therefore, there are no kind of data that occurs or any kind of trends or rhythms that occur during the break time or during the lunch time. So this is a good example for rhythms and trends. The next kind of task that can be carried out is the descriptive statistics, wherein we can see this is an example for descriptive statistics where the number of messages posted online is shown in the form of a bar chart. So from this we can understand who are the people who have talked more number of times. So we can say that Eva and Mary have talked a more number of times or have posted more number of messages in the social network. These kind of descriptive statistics can be understood over the data that has been presented in the form of a bar chart, which is called as descriptive statistics. The next kind of task that can happen is on community and social network. So this is a community or a social network wherein each and every node is represented as a people and the edges are represented as a relationship between the people. It can be any kind of relationship that exists between each and every person. It can be a friend of relationship, or it can be some other kind of semantic relationship that exists between each and every person, which is represented in the form of a node. So this is an example of community and social network. So these are various tasks associated with the data set. The next one is interaction. Interaction distinguishes the information visualization from static paper visualization. With the help of interaction, it is possible for us for the end user to identify some kind of dynamism or some kind of dynamism in the visual that is being shown to the end user. So with the help of interaction, it is also possible for us to differentiate a static paper visualization with respect to some kind of dynamic visual. Analysis can be performed with the help of interaction, and this kind of analysis is a process which is often iterative in nature with the branches and sideway paths. There are various visualization tasks that can be performed on the data set or on the visual as such, and they are given below. Some of the visualization tasks that can be worked on with the data are the overview, which is a collection of data set. Zooming in and zooming out on the objects of interest. It is possible for us to zoom in or zoom out on the objects of interest as such. The next kind of task that can be worked out on a visual is filtering out uninterested items and showing only the interested items to the end user. Another kind of task that can be performed over the visual is the details on demand, wherein the user can only view the details. Whenever he is needed, he can view the details. If it is not needed for him, it is not necessary for the designer to show the details to the end user. Next one is relate kind of task, wherein the user can view the relationship between various entities that are shown in the visual. The next kind of task is the history task, wherein user can undo or redo or refine the kind of output that is shown in the form of a visual. Another kind of task is an extract task, wherein it is possible for the end user to extract a subset of data and visualize what happens. So there are various 7 tasks which can be classified as told already as the overview task, which gives an overview of the entire collection of data set. The filter task, which can filter out uninteresting items. The details on demand task, by which it is possible for the end user to select an item or group to get the details. The zoom task, with the help of which we can zoom in or zoom on to items of interest. The relate task, which helps in relating items or groups within the collections. The history task, which helps in keeping a history of actions to support some kind of tasks like undo, replay and progressive refinement. The extract task, which helps in allowing the extraction of sub-collections of various query parameters. VX Insight is an example visualization toolkit that has been developed by Sandia Labs. This helps to visualize various databases. It is a VX Insight is a licensable product. The elements of database that can be visualized using this VX Insight can be anything. In the case of information visualization, the anything can be some kind of abstract objects like document relationship, company profiles, etc. Or it is possible for us to visualize even some kind of scientific data using this VX Insight, wherein experimental data or numerical values are stored into the databases and are displayed with the help of this VX Insight. So the example screen also shows some grant proposals. We can have a look at the video in the given by clicking on the given URL, and this video shows some kind of interactive capabilities that exist in this VX Insight. So this is a screenshot of this VX Insight. Using this, we can visualize and navigate large data set basically. There are various menus that are available. We can choose from various menus that are available here. We can have an overview of what is shown in the entire screen as such. We can go in for details in demand. We can just zoom in into the objects that are present on the screen. We can also use the mouse button controls for zooming in and zooming out of the object. We can use SQL based queries. We can supply SQL based queries to the database and get various interesting output based on the queries that are given to the database. So this is an example. These are various example tasks that can be performed over this VX Insight tool as such. So the Schneiderman's information visualization interactive paradigm says that overview can be overview, zoom, filter, details on demand, browse, search query, relate, history and extract. So these are various interaction paradigms that are given by Schneiderman's information visualization. All these interaction paradigms are possible with the help of this VX Insight. So it is shown here. You can go in for an overview of the entire database as such. The database, as said earlier, the database can contain any kind of data as such. It can be either some kind of experimental data or scientific data, or it can be some kind of abstract data as such, which is represented in the form of table. So this is an overview of the entire database as such in the case of VX Insight. This is zooming into a specific area that is being displayed to the end user. It is with the help of this VX Insight, I can zoom in into a particular location and see in depth or in detail what happens in that particular area as such. I can also look in for the detailed visualization. This is the detailed visualization of the zooming in part of this VX Insight. There are various user tasks, as said earlier, that can be applied over the data set or over the visual. Some of the easiest stuffs that can take place using these kind of tasks are, it is possible for me to calculate the minimum, maximum, average or percentage in any kind of data set. And these kind of, the data set can also involve one data item, or it can be some kind of multiple data items, or it can be some kind of valued data items. These are certain easy stuff that can be performed over the database. Some of the hard stuff that can be performed over the data that is available is to find out patterns, or to find out trends or distributions, to check for changes that exist over time, to look for certain kind of outliers or exceptions that happen in the data, to look out for certain relationships or correlations or some kind of multi-way relationship that exists between the various data set, to look at some kind of combined min-max effect and some kind of trade-off effects by looking at the data. It should be possible for us to infer certain clusters, groups or comparisons and the context information. It should be possible for us to infer some kind of anomalies and data errors, paths and things like that. These kind of hard stuff are possible only with the help of visualization, whereas the easy stuff are possible with the help of, say, some kind of graph or some kind of Excel sheet itself. Whereas these kind of hard stuff cannot be provided only by an Excel sheet. These can be provided only with the help of some kind of visualization by applying some kind of visualization technique. Some of the basic interaction techniques that can be applied over the visual or on the data set are selecting process, which can take place with the help of a mouse click. I can select a particular item by clicking with the help of the mouse. I can select a particular item by keeping the mouse over that particular item or hovering the mouse over the particular item, or I can select a particular item with the help of the tooltip. I can go in for some kind of lasso tool for selecting a particular item. I can drag and drop a particular item. These are certain basic interaction techniques for selection process. Similarly, there is a process which is called as rearranging process, wherein it should be possible for the end user to move or sort or delete certain items that are visible to the end user, either in the form of a data or in the form of a visual. So in the case of rearranging the data set, it should be possible for the end user to move certain data set as per their wish, to move certain elements in the visual as per the wish. It should be possible for the end user to sort the data that is shown to the end user, or to sort the visual elements that are shown to the end user. It should also be possible for the end user to rearrange the various elements by deleting the attributes that are the elements that are shown to the end user. So this is an example for selection process. We can get pop-up tooltips by hovering a mouse cursor. It brings up certain details by just hovering the mouse cursor over a particular position. I can go in for some kind of mouse selection by clicking on a particular item. It selects that particular items and it displays the attributes of the data point that are being selected. So this is a selected here in this example we can see this example is an example application which is called as a spot fire. We can see that we have selected a particular item and the various attributes associated with that item are displayed on the side as such. This is a selection process, the selection task that can be performed over the visual. Next is the rearranging process. This is an example screen given by a particular visualization tool called as table lens. In this table lens, it is possible for the end user to move the columns or attributes from right hand side from left to right or right to left, so that the user can perform some kind of comparison over the data set. It is also possible for the end user to sort the data with respect to a particular attribute in the table lens. The user can select a particular column and he can ask the tool to sort the data that are present in that particular column, so that the user can look and infer certain interesting patterns out of it. Some of the advanced interaction techniques that can be applied over the visuals other than the selection and rearrangement are brushing and linking process, which can be done over the data set or over the visual that is being shown to the end user. Looking at overview as well as giving the detail of some portion of the data set. Another kind of advanced interaction technique is a focus plus context information, wherein the user is possible to focus to a particular point and look at the context information that is the context information that is related to the focused spot. Another kind of advanced interaction technique is a panning and zooming process. In the case of panning, the user can move from left to right or right to left. And in the case of zooming, the user can move inside and outside that particular data set. Next, the last kind of advanced interaction techniques are distortion-based views. It can be possible for the end user to have some kind of distortion-based views. For example, some kind of fisheye views, which will be helpful for the end user to infer certain information out of the visual as such. So these are examples for brushing and linking with the help of dynamic queries. With the help of this spot fire, it is possible for us to brush and link certain data items with respect to the visual that is shown here. This is a spot fire which has been designed by Alberg and Schneiderman. So this is a visual that is being shown, presented to the end user. The dynamic queries can be generated just by using these kind of slide bars and by assigning various values to the attributes. Automatically the dynamic queries will be generated, and based on these kind of dynamic queries that are being generated, it is possible for the end user to brush or to remove certain data or to link certain data to some other data that exists in that particular data set. This is also another interesting visualization pattern that is shown to the end user, which is being generated by Parvas and by Lederman, which shows the parallel coordinates. So this is an example. Here we can see that it is possible for the end user to look at the various data items, and he can go in for a selected item and remove the other items, and he can see how that selected item looks like, which is called as brushing. He can highlight the brushed items and he can see only that particular item he is actually interested in, and by removing various other items that are shown here. So if you look at the overview and detail process, these are two different views. That is, we have separate views, one for the overview view and the other one is for the detail view. There will not be any distortion when showing the overview and the detailed information, and both the overview and the detailed information are shown simultaneously to the end user. One of the drawbacks here is it requires the viewer to consciously shift his focus of attention either from the overview window or to the detailed window. So this is an example visualization which is being given in the traffic.511.org, which gives a good example of this overview and detail part. So here we can see that there is a small window which shows an overview part and the big window which shows the detailed part. In the overview part, the user can select the objects of his interest, and based on the selection of the user and based on the objects of interest that are being selected, only that particular portion is being enlarged and shown in a detailed manner to the end user in the bigger window. So this is an example for overview and detailed task that can be performed over the visual. The other one is a focus plus context information. A single view shows both the focus as well as the context information in detail. The contextual information should be very near to the focal point. Distortion may make some parts hard to interpret also in the case of focus plus context approach. Distortion may sometimes obscure the structure in the data. Some of the example visualization technique that uses this focus plus context approaches from Xerox PARC, it is a table lens, the perspective wall and the hyperbolic tree browser. Let us have a look at all these visuals. The first one is a table lens from Xerox PARC. So here we can see the entire context information that are shown along with the focused information which is being highlighted. The highlighted portion is a focused information that is of interest to the end user. Along with this focused information, the context information is also shown by the side to the end user, so that it is possible for the end user to compare the focus information with that of the contextual information that is available. Another example is the perspective wall from Xerox PARC, wherein we can see that the focus plus context approach is applied here. Focus is on the specific entities that are presented in the front side of the wall. Along with this focused information, the context information is placed in the side walls of the figure, so that it is possible for the end user to understand what is the kind of relationship that exists between the focused information as well as the contextual information. Not only that, in this we can understand that the distortion technique is also applied to show the contextual information to the end user, because without applying these kind of distortion technique, it is not possible for the designer to show the entire information in one screen, because the focused part alone is shown with much clarity and the contextual information is shown using by applying the distortion technique. So this example is from the perspective wall. The other one is a hyperbolic tree from Xerox PARC. So here also we can see the focused information that is being seen more clearly along with the contextual information. With the red one is a focused information. We can look at the relationship of the focused information with respect to various other nodes using this contextual information. So this is also a very good example of focus plus context approach that is being applied over the hyperbolic tree. The next kind of interaction technique that can be applied over the visual is a panning and zooming technique. Panning and zooming helps in moving helps the end user moving from one location to another location, and either from left to right or right to left, and also from inside to outside kind of movement. There are multiple levels of resolution in pan and zoom. The view changes depending on the distance from the viewer to the objects. These sometimes distortion based techniques are also applied to keep a steady overview, and using these techniques it is possible to make some objects look larger while simultaneously shrinking other objects which are not of interest to the end user. So let us first see what zooming is. Zooming, there are different types of zooming that can be applied over the objects of interest. The first one is the standard zooming, wherein we get close in to see the information in more detail in the case of standard zooming. Example is zooming into the Google Earth information to get a lot of information about some kind of location or some kind of traffic that exists in a particular location. The other kind of zooming is an intelligent zooming, which shows the semantically relevant information out of proportion to the end user. It is possible for us to speed up and slow down the process of zooming as such. Some of the examples of this are speed dependent zooming. The next one is semantic zooming. Semantic zooming can be conceptual as applied to simply by reducing the pixels. Some of the tools which help in semantic zooming are PAT++ and Piccolo projects. So this is an example of a speed dependent zooming which has been designed by Igarashi and Hindley in the year 2000. We can see how the speed varies by looking at these various visuals. The first figure is very clear, whereas when we look at the last figure, it shows some kind of zooming out option that has been applied over the image as such or the visual as such. If we look at the differences between standard and semantic zooming, we can see that in the case of standard zooming, the view depends on the physical properties of what is being viewed. Whereas in the case of semantic zooming, when we zoom away, instead of seeing a scaled down version of an object, we see a different representation of the object that is shown to the end user. The representation also shown depends on the meaning to be imparted to the end user as such. Some of the examples of semantic zoom are information maps. For example, it is possible for me to zoom into a restaurant and look into the interiors of the restaurant, and I can also see what is being served inside the restaurant. Maybe I can also zoom based on the price. I can see the expensive restaurants first, and then I can zoom in till I get the restaurants of my price range. Next one is browsing and information service. That is, we can charge the user successively higher rates for more detailed information. Whenever the designer is going to provide more detailed information, the end user can be charged accordingly. These are certain examples of semantic zooming. Then infinitely scalable painting program is also an example of a semantic zoom program, wherein I can have a close-in view of the paint sheet that is being shown to the end user, where I can see flecks of paint. When the paint is being moved farther away, I can see some kind of paint strokes. Farther still, if I see the paint, I can get a holistic impression of the painting. And farther still, when the painting is placed at a very long distance from the end user, I can see the artist sitting and doing the painting. PAT++ is another user interface which helps in having, which helps in making the end user move across the entire surface of the plane. This is an infinite 2D plane as such, and you can infinitively get close to the surface also. We can navigate, the end user can navigate by panning and zooming process. Panning is moving around on the plane, and zooming, as said, is moving closer to and farther from the plane. It is also possible for us to perform navigation in this PAT++. So how do we keep from getting lost? We try to animate the traversal from one object to another using some kind of hyperlinks. If the target is more than one screen away, we try to zoom out, pan over and zoom back in. The goal is to help the viewer maintain the context information with the help of PAT++. So these are examples of PAT++ screenshots, which is called as PAT++ tour. The role of portals. All this panning and zooming can get more confusing. Portals allow for zooming a small piece of data set while keeping everything else in the same position. PAT++ is a very stretchy sheet as such. A portal is more like a special window into a piece of a sheet, and that window behaves independently with respect to the rest of the windows. So these are examples of space scale diagrams that are designed by Furness and Bedresen in the year 1995. The original figure is being shown at various scales. Here in this we can see that the horizontal axis is standard, whereas the vertical axis is a scale axis. So the user has a fixed size viewing window as such. We move this fixed size viewing window through the 3D space, which try to yield all possible sequences of panning and zooming options. So a point in this case is transformed to a ray, and the circular region becomes a cone instead. So if you move the origin of the 2D plane, the properties of the original 2D picture do not change as such. Therefore, the absolute angles between the rays should not be assigned any meaning as such. So these are two different views of the space scale diagram. We can think of this in terms of one-dimensional space scale diagrams also. When zoomed out, you can see a wider set of points. This is an example of a one-dimensional space scale diagram as such. There can be some kind of pure panning, that is moving from one location to another location as shown in the A section. It can be some kind of pure zooming wherein I move from one location to another location, that is outside to inside as in the case of B. I can also look at panning and zooming options wherein I change the position as well as I try to move in and out. So these are some examples of space scale diagrams. Using these space scale diagrams, it is possible for me to implement semantic zooming also. So in summary, if we look at the summary, what we have studied in this particular module, we have looked at various tasks and interactions, the definition of what task and interaction is. We have looked at various example application and information visualization related to task and interaction, and it is also possible for us to choose the better option based on the kind of goals that gets applicable over the various information visualization interaction process. Thank you.